Greetings and welcome to Talk a Little, Learn a Lot, the American Society of Naval Engineers podcast. I am your host, Stephen Phillips. In this podcast, we talk a little and learn a lot about naval engineering while inspiring the next generation of STEM professionals. Today, I'm joined again by Vice Admiral David Lewis, ASNE's president, to discuss an article he recently posted entitled The Industrial Integration of Design and Production in the World War II U.S. Emergency Destroyer Escort Shipbuilding Program. This will be the first in a series of at least 2 podcasts, so watch for another similar topic on submarine production. Vice Admiral Lewis served as a surface warfare officer. His assignments included USS Spruance, USS Biddle, and USS Ticonderoga. Ashore, he served as Assistant Chief of Staff for Maintenance and Engineering, Commander, Naval Surface Forces, the Naval Secretariat Staff, Naval Sea Systems Command Staff, and Aegis Shipbuilding Program Manager. Upon selection to flag rank in 2009, Lewis served as Vice Commander, Naval Sea Systems Command, and then served 4 years as Program Executive Officer Ships, where he directed the delivery of 18 ships and procurement of another 51 ships. From 2014 to 2017, he served as Commander, Space and Naval Warfare Systems Command, where he led a global workforce of 10,300 civilian and military personnel who designed, developed, and deployed advanced communication and information capabilities. In May 2017, he assumed command as the director of the Defense Contract Management Agency in Fort Lee, Virginia. Admiral Lewis now serves as Senior Vice President of the Maritime Business at Leidos, a Fortune 500 company that provides innovative solutions for defense, intelligence, civil, and health areas. Vice Admiral Lewis, Dave, thanks for joining me on the podcast. I look forward to our discussion.
Thanks for having me. This is always a pleasure. You're a good interviewer, and it's a good forum. So thank you for doing this.
Well, thank you for that. I'm interested. What first drew your attention to the World War II Emergency Destroyer Escort Shipbuilding Program as this case study for industrial integration between sort of design and production?
So I was reading, I just finished the NAM Rogers' latest book, The Price of Victory. It's a 3rd volume in a 3-volume history of the Royal Navy. And I like his stuff. And it's a kind of history I enjoy reading. It's very meaty and beefy and full of little stories. And one of them was talking about the Flower class corvettes that Great Britain brought into service as an urgent emergency convoy escort ship. And so he talked about that. I'd heard about it. I was sort of familiar with it. He provided some more detail. And then he talked about the follow-on programs. There was a Canadian follow-on program. And then there was a U.S. Destroyer Escort follow-on program. I knew about the U.S. Destroyer Escort program, but I didn't realize it was part of a thread that started with the Flower class corvettes. And so he described it as maybe 3/4 of a page, half a page. And I said, well, that's really interesting. And I had been involved in the building and commissioning of the USS Mason, which was named after one of the destroyer escorts of the Bulka class, which was the Navy, one of 2 ships in the Navy that was had a Negro crew and white officers. So it was like the Tuskegee Airmen, the Navy version of that. And so I talked to the crew members. So I had some prior familiarity with the class. And so I jumped on the internet and started doing some research, and this whole story came out. I mean, I had no idea any of this had happened. And Gibbs and Cox was a design agent. I am familiar with them, and they had done the designs for the Victory ships and the Liberty ships. So there was a connection there. So I spent a few days digging around in that, and it was amazing. I had no idea. I mean, this was a total learning experience.
Well, I really enjoyed reading the article and learning about it myself. You described how that wartime urgency forced new levels of coordination between the naval architects, the engineers, and then the shipyards themselves. What were the most significant innovations that came from that collaboration?
I don't know if you've read Freedom's Forge, but if you haven't, I'd recommend it. There was a the through story for industry and production in World War II is kind of the same across the board, and this one's a particularly interesting example. Before the war, military stuff tended to be bespoke designs, a very craftsmanship based, small industry, blinking away, building, I think, well, actually, destroyer escorts didn't even exist before World War II, but building five or six a year, 10 a year of something. And then when the war started and it became apparent that that wasn't going to be good enough, people had to start changing. And again, back to the flower, they were bespoke. It was a bespoke design, craft build in small English, British shipyards, and that was fine because they had no time to do anything different. And then the Canadians brought in more of an industrial approach to it with classes that they built. And then the destroyer escorts were kind of a culmination of that trend. And they implemented a production-based view of shipbuilding. So they didn't want the craftsmen. They wanted to build a lot of them very quickly. And that the craft industry in the U.S. for shipbuilding didn't exist. So they had the Navy working with Gibbs and working with industry had to fundamentally change their view, our view of how to build a ship. And they went to, I guess I would call it the American system, if you're familiar at all with that. Grew up in the 19th and early 20th century, where you have interchangeable parts and there are standards and interfaces. And that's what happened in the destroyer escort design was they brought that production mindset, that American system, standard supply chain into the craft industry that was shipbuilding in the United States at the warship building in the United States at the time, and that little the article and what they did talked about how that happened, and it was remarkably well done. And it wasn't a lot of people think, many people think that improving or increasing production rate means you just buy more machinery, you buy more lathes and drill presses, and you buy a big building and stick in a bunch of stuff. And what I liked about the destroyer escort case is that it was very clearly much more than that. It was about learning, it was about organization and leadership, and the Navy took a leadership role. Gibbs and Cox, as the designer, designed for production at multiple sites with multiple OEMs, and they tried to make it as modular as possible so that there were four different subclasses of ship based on their propulsion plans, but the rest of the ship was common. So when they did the design, the Navy and Gibbs did the design, many of the components that were used in those four classes were the same. So you could set up a facility that would build only, bows or only superstructure, and then those would go on any ship, and that brought in non-shipbuilding industries. There's, bridge builders, steel erector kind of companies that they could hang steel just fine. Never built a ship before. In this case, the two came together beautifully, actually, and they were able to build, I think, what's the number, 563 ships in 3 years. I mean, that's amazing, and from nothing, and that was the draw for me was the organizational and learning construct that was implemented in this program, and how well it was done and how quickly it was done. Mostly because it was leveraging off the existing capabilities of industry in the United States, commercial building, steel, steel erector facilities that could hang steel, but not necessarily a ship. And it was just incredibly well managed, incredibly thoughtfully done. And it was a riff off of Victory ships and Liberty ships, and I thought that was in a warship kind of flavor to it, and I think that applies to today. I mean, we'll talk about that later, but
Yeah, for sure. So, what parallel do you see between that World War II shipbuilding integration effort and today's challenges in programs like unmanned systems and
uh,
digital shipbuilding or rapid prototyping? Like, what do we learn from that for today?
well, I think today we're in a similar case where we have some very good, very capable and effective warship designs, which are being built in very capable and very competent shipyards, and they're maxed out. They're building as fast as they can. I truly believe. I mean, nobody's slacking off. It's, they're going as booming as fast as they can. However, as in World War II, we're facing an adversary. We're not in combat, of course. This is a phase zero, I guess we'd call it, who is outbuilding the U.S. Navy, outbuilding the U.S. military shipbuilding industry, naval shipbuilding industry, significantly. And I think we think that we need to catch up. We need to build more ships. Exactly analogous to the early World War II scenario. As in a combat situation, this is not there. Um, so the principles, the the production and industrial principles that made the DE Destroyer Escort program so successful, I think apply today as well. People tend to think of the naval industrial base as six shipyards, the big six, which is true. But as prior secretaries of the Navy have pointed out, there's 154 shipyards in America, not six. There's lots of shipyards in America. So the other 148 are building ships and boats and kind of everything in between. And that is all latent capability in my view. And so the things that the Navy did in 1941 and 1942 to build destroyer escorts, I think are applicable today in that way. Now, they're not going to be those shipyards in 1941, for the most part, weren't building battleships or cruisers. A few of them built aircraft carriers. So they weren't building those super exquisite ships, but they were building out the what turned out to be the bulk of the fleet that was needed for operations. And I think that situation is also analogous today. The destroyers and submarines and aircraft carriers, those building those, and those are fine. But that fleet of just those ships is not sufficient. Necessary, but not sufficient. So I think the Navy needs to expand down at the lower end of the spectrum of shipbuilding, and that's where the destroyer escort model comes in beautifully. And however, that requires a change in thought, in paradigm, even if I can use that word. That warships don't have to be built in one of the big six. Warships don't have to have mil spec welding all the way through, and those sorts of things. And I think the DE case really illustrates what you can do when there is a strong sense of urgency, compelling demand, and you think differently as a Navy and frankly as an industry.
Yeah. You rightly point out we're in phase zero right now, but something then did happen during the Second World War that changed things, and that is there became this wartime industrial culture, both in the Navy and in the private shipyards. How did that shape the success of this integrative effort, and what aspects of those culture are still relevant today? Maybe I'll reflect on back then. It was like the whole nation got behind this huge effort, right? And so, what do we do today if that's part of the element to get everybody behind this?
There's a quote from the 1650s in England or something where a guy said the prospect of a hanging, imminent hanging, helps focus the mind, and that's a crisis thinking. We have all these standards. I've written about this in the Naval Engineers Journal. We build a intellectual structure, an organizational structure that has standards and protocols and processes, and we use it and we like it and it works. And then an outside pressure comes in, and the regular stuff can't or isn't responsive, can't be responsive. And then now there's a discontinuity there. What I know and what I do isn't working. Do I try to do more of the same, or do I change my views? And that's Freedom Forge talks about it. Other Kennedy wrote a book on the same topic. Title escapes me. Um, but in that situation, those standards which the organization is beholden to and is serving are not necessarily the standards that should be retained into the future. And the organization has to break out of that mold, open its thinking to incorporate other things. And that's something that actually happens fairly often. You're in a factory and somebody invents a thing called a computer. Can you put a computer in a lathe or in a milling machine? No, we've never done that. We're not going to do that. Well, actually, yes, you can do that. And this is that approach. Is we've been doing this. We're doing it a long time. We like it. We're comfortable with it. We know how it works. Yet we can't meet the demand signal that's coming to us. And that's that intellectual transition, that philosophical transition that this and a couple other examples, cases, I think, show that it can be done. It's not impossible, and we can behave in a different way. But that requires abandoning or changing very mature, understood, loved standards and procedures, and that's hard. That's hard for people to do. It's harder for organizations to do. And what I see in the Defense Department today is, and actually for several years now, a decade at least, is that struggle with that. And the driving factor is the circumstances are different. That process was set up in a certain environment, a certain world, a certain set of constraints and rules, and it worked fine in that situation. But we're in a different environment today, and that set of constraints and rules doesn't work anymore, or doesn't work as well as it did before. So we need to change. And cases like that, I like cases like this because they illustrate that it can be done. And Liberty ships is a case, purely commercial. Destroyer escorts are a case, mixed commercial military. I think later we're going to talk about submarines. That's another case, purely military. And there are a lot of those out there, and organizations have been responsive to that outside, and that's a leadership role, that's an engineering role, and I think that's very consistent with what ASNE is on this earth to do, is point these things out.
Yeah. How did the use of standardized plans and centralized design coordination then affect the efficiency and that consistency across each of those shipyards?
Well, that's kind of it's. I've struggled with that because standards are inherently retrospective and regressive. Once you set a standard, the purpose of a standard is to stop change. So if you're implementing a new technology, if you set standards too soon, you've stopped the implementation of a new technology. On the other hand, when you have something fairly mature like shipbuilding, I mean, it's not like we've been building ships for 5,000 years, plus or minus a couple of thousand years, something we know well and we've been doing a long time. It's not a completely new thing. It's taken the current process and kind of going, bumping it a little bit. And in that case, standards are progressive in the sense that in a craft environment, every shipyard kind of did its own thing in its own way, and it had its own vendor base. So it always bought its valves from my brother-in-law Bill, and always bought its piping from Joe down the street because he's been my supplier for 50 years. And in the Destroyer Escort program, that wasn't the case. The Navy said you're going to buy all your motors from this company, you're going to buy all your pipe from that company. You're going to buy, switch gear from these companies. I outlined all of them in the article. And so there was this entire ecosystem structure that was defined by the Navy, Gibbs and Cox, and a couple, I think, of the big shipyards. And then that whole system was imposed on everybody else. And I think that's what allowed for the efficiency and the speed is the shipyards then focused on just building ships. They didn't have to worry about supply base. They didn't have to worry about engineering. They didn't have to worry about any of that. The Navy provided the engineers. There was a structure that the Navy set up so that if a shipyard had a problem, they could snap their fingers and, engineer so-and-so, engineer Joe would show up and, work it out. And there wasn't a lot of room for variability because all these different bits had to come from different shipyards and they had to fit together and work together. So the shipyard wasn't free to kind of wing it, if you will, for a lot of the shipbuilding. So they got to be pretty efficient. And the stats I had, I couldn't find really hard stats, but the soft stat was they had a 50% reduction in labor hours through the program. Now, obviously, material cost is a lot of the cost of a ship, but touch labor hours are really important, especially when you're building a ship. And 50% reduction that's especially across, I think it was 15 yards. That's impressive to get that kind of efficiency that quickly with 4 different classes, lots of different suppliers and vendors. So that was a difference. Standardization was used as a tool to drive efficiency, reduce variation, and drive commonality among a very disparate group of shipbuilders and not shipbuilders who were building ships. and again, there's a lesson in that you can do that, especially if you're transitioning out of a bespoke, exquisite kind of environment. And that's one of the big mental changes that leaders have to go through is that.
It's amazing the amount of efficiency that came through that
Yeah.
process. Are there particular engineers, shipyard managers, or naval officers whose contributions stand out as pivotal in making this whole process work?
I didn't get to the point of names. That would be for a later iteration.
Right.
But I think the Bureau of Ships, kind of a precursor to NAVC, gets very high marks. Usually, when I'm reading about the government doing something amazingly different, it's not very complimentary. In this case, everything I read and everything I saw in writing the article was that the Navy was in the U.S. Navy, Bu Ships was in a leadership role. And Gibbs and Cox at the time was a fairly new company, young, fairly remarkably experienced, principally in warships. So they were a close partner with the Navy in that. And industry was remarkably receptive as well. I didn't see a lot of drama. I'm sure there was. but I haven't found it yet. I'll keep looking though. I'll keep looking. I'm sure it was there. And the ships performed well. I mean, my Mason experience when I talked to the Mason sailors who sailed on the Mason, one of the DEs, they made a big deal about the ship was built for 1.5 crossings of the Atlantic. That was the standard, and they fixated on that, especially the half part. And so it wasn't made to be a 30-year or 50-year ship. It was made to be 1.5 crossings. If it got a convoy across the Atlantic, uh, you were doing great. And that, again, back to standards and all that, that fundamentally changes a lot of what an engineer or a shipbuilder does with a ship in the design and construction. They adopted new technologies like welding. That was brand new back then. But they also went with established technologies, steam and stuff. So I think the Navy and the ship design agent were very clever about integrating new and old technologies, adapting them to people that had never built a ship and also people who had experience building ships so that that whole structure could come together in an organized way and be successful at building the ships. And like I said, I think later we're going to talk about an example where that didn't happen and why it didn't happen. And it was not technology, it was not engineering, it was organization, leadership, and learning.
Yeah, I think you're talking about when we do our part two on the
Yeah.
submarines. But I also want to allude to the fact and ask about how did the destroyer escort change from, or how would it differ from other wartime efforts like the Liberty ships or the fleet destroyers? Was it different in their processes and approach?
Well, I mean, the difference with the Destroyer Escort is it had weapons and it had some sophisticated electronics. I mean, U-boat warfare in 1942 was at the bleeding edge of high technology. Rogers really talked about that a lot in his book, The Price of Victory. You know, radar was new. How to use radar, we don't know. It was constantly changing. Sonar, ASDIC, what the Brits called it. Depth charges. They were learning about how German submarines operated. So they had World War I depth charges. Well, it turned out that wasn't right. And so they had to do a lot of changes with that. They had Hedgehog, which was a new forward projecting anti-submarine weapon. And so there was a lot of innovation at the weapons, communications, and radar side of the ship, which is unique to that ship. The Liberty ships didn't have that. And so that part of it, the combat systems integration, I guess would be the term we would use today, that was new, and that's all government stuff. So it was a war. It was a warship, and that's what was different about it and how that got integrated. I did not get into, but I think that would be worthwhile. I know how it was done, for instance, with the MRAP program, which is analogous to that. That was done by a separate activity and a government activity that did that. I'm not sure. I don't know how the DEs did it, but that was what was different about it was the weapons and the C4I suite and the radar. And there were changes as that over the 3-year period. There were significant technology changes in warfighting for those ships.
Yeah, for sure. And when you refer to MRAP, you mean the mine resistant armored personnel carriers
Yep,
that was
yep,
for the IED fight in Iraq and
yep,
Afghanistan. Yeah,
exactly.
indeed. So clearly, you wrote this article because we want to highlight the past and share those lessons and bring those forward. Is there any from this particular case study that you're concerned about? Like, if we don't talk about this and bring it forward, that this a particular lesson is going to be lost?
I think it's that latent capability in American industry. I mean, that's what came out of Freedom's Forge. That's what came out in the Liberty ships. Um, that if you just change the rules a little bit, change the standards a little bit, change your expectations a little bit, uh, um, so how long is the ship going to be in service? I mean, Liberty ships, I think it was one crossing. And so if you change that a little bit, there are, it opens a whole new world to production and to the warfighting environment. And clearly the warfighters have to buy into that. But that has to do with expectations. What do you think is going to happen in the war? And I'm also reading Masters of the Air right now. I'm just finishing it up. Interesting stat. Before the war, the Army Air Corps thought their bomber raids into Europe would be 25, 30 airplane raids, and they thought they would lose about 300 airplanes in the entire war. Um, by 1944, they were flying 1,000 plane raids a couple times a week. And on D-Day, by D-Day, not even the end of the war, but by D-Day, they lost almost 3,000 bombers in combat. So if your assumption is you need 25 or so every raid and you're going to lose 300 airplanes, you do things in a certain way for the industry to support that. New CNO uses the word foundry. I like that a lot. You call on the founder. I need, 100 airplanes a year. Okay, I can do that. I don't have to be too special for that. When you ring up, I want I want to replace 3,000 airplanes in 2 years, and I want to have 1,000 airplane raids twice or three times a week. That's a different signal to the foundry, and that requires different behaviors. And the bomber stories are well known. The Liberty ship story is pretty well known. The Destroyer Escort story wasn't well known to me, certainly, and I've been doing this a long time, and I had not encountered it other than through the Mason. So I don't think it's very well known, and so I thought it was worth highlighting that. It's analogous to all of those things I've talked about. But again, the perception was U-boats weren't that big of a threat. The Germans weren't going to do much with that, and we don't need convoy escorts that much. And I was wrong. And so then you get the Flower class, you get the Canadian River, I think a River and Captain class, I think they were called, and then you get the Bulkleys, and that's how you flesh out the force in the face of a sudden and unexpected warfighting demand signal.
Yeah. Masters of the Air, is that Stephen Ambrose, I believe?
No, it's Miller. Miller's the author.
Okay.
Ambrose did stuff like that. It's
Right.
interesting. I don't know if we have time, but the TV series is not at all like the book.
Mm,
The TV series was made to be like Stephen Andros and Ambrose, the
right.
Band of Brothers and all that. And then I read the book after I watched the TV show, and what the TV show did is in the book there's a lot of vignettes about pilots and doing things, and all of that kind of got scraped off, and that made the TV show. The book is about the history of the 8th Air Force in
Mm,
Europe strategic bombing. Very much more substantial topic, I guess. And so you get a twofer from the book. You get all the stories that turned into the TV series, and then you get all the generals and the politics and the theory and the Duhay and
right.
what the Germans did and the technology and all that stuff, the training system and all that kind of stuff. So it's actually the book's very good,
Mm,
but it's don't read the book if you're expecting to get a Stephen Ambrose Band of Brothers kind of story.
okay. I do. I always think it's counterintuitive that in the Second World War, most people will think the most dangerous place to be is on the front as an infantry person. That's not the case. It's more dangerous to be in the air and with the
Yeah,
8th Air Force, and even more dangerous to be at sea.
yeah,
But yeah, it's
yeah.
maybe counterintuitive.
A stat that I remember from the book was this is Army, of course, so it's all
Mm,
Army.
right.
In the Army, if you casualties in the ground in the infantry were 1/3 killed in action, 2/3 wounded. And you're absolutely right. In the Army Air Forces, I didn't know they changed their name, but they did. It was exactly opposite. 2/3 killed in action, 1/3 wounded. That's scary.
Yeah,
I had no idea. So I've acquired a new admiration for that community, and how they and what they had to deal with, and how they dealt with it. It's an amazing story. It's an excellent book. I highly recommend it.
absolutely. As president of ASNE, how do you see the society helping to foster this kind of approach and integration spirit that's going to create success in wartime shipbuilding? Should we move beyond phase zero, as you said, and
Well,
apply it
hopefully
to
not.
tomorrow's naval challenge? I hope we remain in phase zero, but we're
Yeah,
all
yeah, yeah.
those of us in this field obviously are anticipating. So
Yeah. So the society was founded in 1888. There was no war going on at the time. It was phase zero, and the reason the society was founded were there was all these new technologies coming into the world. It was the birth of the second industrial revolution. You had steel, electricity. Shortly following was internal combustion engines and aviation and radio and torpedoes and weapons were changing. Guns went from cannons to naval rifles. Shells went from solid shot to exploding with fuses and all that stuff in them. And the U.S. Navy was not handling that well. There were a lot of deficiencies in everything. Navy was talking about buying stuff from the Italians and the British because they were the leaders in those technologies, and Germans, and and the Congress said, nope, we're not going to do that. You're going to figure it out. And American Society of Naval Engineers, a lot of the other professional societies, NAMI, ASNE, Naval Institute, later the Navy League, all those societies were born and created during that time of technology transition. And our mission is to be a forum for education and exchange of knowledge, bring industry, academia, and the Navy together, identify and define and discuss best practices and opportunities and new technologies and how do we do that and build relationships. And that's what ASNE is for. That's what we're founded to do, whatever that is, 150 years ago. And I should know, sorry. and and that's exactly applicable today. We did it in the second industrial revolution. We did it in the third industrial revolution. It was the 1950s. That was radar, jets, rockets, space, all that stuff, Aegis, Polaris, nuclear power. We did it then. And now we're in the fourth industrial revolution, and we need to do it now too, because it's exactly analogous. And now it's AI and edge to cloud and ubiquitous computing and ubiquitous satellites and all that stuff, quantum computing. Those are also uh, disrupting what we know and understand in naval warfare. And I think we, the society, have to fulfill our role as an agency, an agent of communication and interaction and knowledge and learning, bringing together industry and academia and government to figure out how to incorporate these new technologies and incorporate these new ideas into maritime systems. I'll broaden that a little bit. So it's not just the Navy, it's Coast Guard, it's MARAD, it's uh, industrial shipbuilding or shipbuilding industries and stuff. So I think we have a very important, very relevant current role in that. We have a proud history of what I call motors and rotors. That's good. That's excellent. I think our future is in AI, machine learning, quantum computing, integrated combat systems, ubiquitous space, those sorts of things, because that's the technologies of the fourth industrial revolution. And we missed the boat on the second one early on. That's why we exist. We can't afford to miss the boat again.
Yeah,
No pun,
that is
no
for
pun
sure.
intended. No pun
No,
intended.
yeah, right. For sure, but for sure. Well, and then thank you, Vice Admiral David Lewis, for taking time to discuss the World War II Emergency Destroyer Escort Shipbuilding Program. And we've already said this, sir. Of course, we are going to have you back on in the future to talk a little, learn a lot. The podcast of the American Society of Naval Engineers.
Thank you very much. Appreciate the invitation.